Hey, the topic in this video is exponential functions differentiation. This corresponds to section 3.2 in our textbook. So again, this unit, going back, picking up all the little pieces we left behind throughout the chapter so far. Now looking at exponential functions, specifically the natural exponential function, okay? This is one of my favorite derivatives ever. That should be later. Right now we're looking at some algebraic review, sorry, got mixed up a little. So remember, e to the x, ln x are inverses of each other. So to say, they undo each other. Like addition and subtraction, or multiplication and division. So if you ever want to get rid of one, introduce the inverse. So you want to get rid of e, take the natural log of both sides. The ln and e cancel out. The x plus 1 has nothing like holding it up, so it comes down. Then to solve for x for good, subtract 1 from both sides. You have your solution. Again, inverses. You want to get rid of ln, introduce the inverse. Exponentiate both sides. I may have made the word up, I don't know. E to the ln, 2x minus 3, that falls down. So 2x minus 3 equals e to the 5th. That is some weird decimal. Leave it as e to the 5th. Add 3 to both sides, and then divide by 2. And you have your solution for x. Getting a pretty quick review of some algebraic topics. Now this is my favorite derivative rule. Derivative of e to the x. It's so perfect. Just e to the x. E to the x. The natural exponential function. Because it's so natural. The position is the velocity, is the acceleration. They're all equal to each other. If you have a chain rule, just use your chain rule tools from your toolbox. Just use that chain rule. So, derivative with respect to x, v to the power 2x minus 1. This is technically a chain rule problem. 2x minus 1. That is inside. E is the outside. So chain rule, you know, derivative of outside, leave inside alone, times derivative of inside, okay? So this is great. Derivative of the outside, derivative of e. Well, derivative of e is e. So, derivative of e, leave the inside alone, times the derivative of the inside. Just 2. And there you go. Pretty simple stuff, okay? Got the alarm going off. You're done now, okay. So looking at example B, same kind of deal. Taking the derivative of e. Let's go ahead and rewrite it. e to the negative 3x to the negative first power. Okay? To kind of make it simpler to work with. So derivative of e is e. Leave the inside alone. Times derivative of the inside. So bring the negative 1 down. Negative 1 times negative 3 is 3. Decrease exponent by 1. So you can have 3 over x squared times e to the negative 3 over x. And pretty simple stuff. Derivative of e. So they may want you to find relative extrema. Same type of process, okay? As before, finding relative extrema, take the derivative, set the derivative equal to 0, then use those critical numbers. But now you have e in the problem. So all that same stuff, just using e to the x in the problem. So using that differentiation rule. So f of x is a product rule. Go ahead, split it up. Get our puzzle pieces. And then put our puzzle pieces together. So we have f prime of x equals 1 times e to the x plus, go ahead and do the other diagonal, x times e to the x. So before we set this equal to 0, let's pull out an e to the x. 1 plus x. So right here, in case you're wondering, I'll write it down, did kind of a greatest common factor. And now set f prime equal to 0. And now do 0 product property. So either e to the x equals 0 or 1 plus x equals 0. Now e to the x can't equal 0, so that kind of goes away as a possibility. And right here, x equals negative 1. And to kind of confirm, I assume negative 1 is a relative extrema. It's the only one that came up on the problem, but let's check it just to be sure. So pick an x value to the left of negative 1, pick an x value to the right. F prime and negative 2, you plug that in, you're going to get a negative value. So we're decreasing. F prime is 0, plug that in, you're going to get a positive value. So we're increasing. So we have a relative minimum at negative 1, comma, negative, what would we get if we plug in negative 1? E to the negative 1. 1 over e times negative 1. Negative 1 times 1 over e, negative 1 over e. Then sketch a quick graph, so get a quick table of values. So x and f of x. Let's go -2, -1, 0, and 1. If I need more, I'll make more. So let's plug these values into our original function. So -2, plug that in. -2 times e to the -2. That's a pretty small number, pretty close to 0. -1 times e to the -1. That's still a small number, but further from 0. Plug in 0, you get 0. Plug in 1, you get e to the first. So I think we kind of got what we need. E is about there. So sketching a quick graph. And I'm sure better graphs have been made in the world. Alright? I think I got to everything, but anything I didn't get to, make sure you finish that, okay?